Okay, this is 2011, AIME II Problem 5. So we're told that the sum of the first 2011 terms of a geometric sequence is 200, the sum of the first 4022 terms is 380, and they want us to find the sum of the first 6033 terms. Okay, so there are a bunch of different clever ways to do this. You can kind of skip steps and shorten the amount of time it takes you to solve the problem, but I'm just going to solve it in the most straightforward way, kind of realistic way that I would solve it. Doing it on a test. So I'm just going to use the formula for the sum of the first n terms of a geometric sequence, and that formula is S sub n, the nth partial sum, equals the first term, which I'll just call a1, times 1 minus r to the n over 1 minus r, where r is the common ratio for the sequence. Okay, so this gives us that S sub 2011 equals a1, which we don't know, times 1 minus r to the 2011 over 1 minus r. Likewise, S 4022 equals a1, 1 minus r to the 4022 over 1 minus r. And then we want to know what S to the 6033 is. Okay, so let's use the information that we have to try to solve for either A1 or maybe R. It turns out solving for R is probably going to be our best bet. Okay, so we have that S of 2011 is equal to 200 and S of 4022 is 380. So we can go ahead and use this to solve for r to the 2011. So we have 1 minus r times 200 equals a1 times 1 minus r to the 2011. And then we also have that 1 minus r times 380 is equal to a1 times 1 minus r to the 4022. Okay. Just divide both sides in order to solve for 1 minus r. And then we get, let's see, we have, in order to solve for a1, so we have 1 minus r times 200 over 1 minus r to the 2011 equals a1. And then we also have 1 minus r times 380 over 1 minus r to the 4022, that's also a1. So now we can set these equal to each other, and when we do so, you're going to have the 1 minus r's will cancel out, so you just have 200 over 1 minus r to the 2011 equals 380 over 1 minus r to the 4022. Okay, and then this value in the denominator of the right-hand side equation is actually a difference of squares, because this is really 1 minus r to the 2011 all squared. So that means we can factor it as a difference of squares. So now we have, let's see, we should have 380 over 200, sorry, is equal to 1 minus r to the 2011, 1 plus r to the 2011 over 1 minus r to the 2011. Those cancel. So that gives us that r to the 2011 is equal to 19 tenths minus 1, so that's just 9 tenths. Okay, so now we can go ahead and solve for a1. So our equation for S sub 2011 is as given above. So now we can plug in. So we have a1 times 1 minus 9 tenths, so that's just 1 tenth, over 1 minus 2011th root of 9 tenths equals 200. So then a1 is equal to 2000 times 1 minus 2011th root of 9 tenths. And now we can actually just directly solve for S sub 6,033. So that's equal to A1, which is 2,000 times 1 minus 2011th root of 9/10. And then times 1 minus r to the 6,033, which is r cubed. So that's going to be equal to this 9/10 cubed. So that's 1 minus 729 over 1,000. And then that's going to be all over 1 minus r. So that's 1 minus 2011th root of 9/10. So obviously these factors cancel in the numerator and denominator, and we're left with just 2,000 times 271 over 1,000, which just gives us 542. And that's it.